All right, we're going to look at problem number 1 from the Prasolov chapter 2. So here we are given a circle. So, circle. And we have a point A outside the circle. And we have two rays, ray AB and ray AC. We'll put B here and C here. That intersect the circle. And we want to prove that the measure of this angle, angle BAC, we want to prove that that's equal to half the difference of the angle measures of the arcs of the circle confined inside this angle. So let's give these 2 points some labels also so that we can state what it is we're trying to prove. So we want to show that angle BAC is equal to half the measure of arc BC minus the measure of arc DE. And this angle BAC is what we commonly refer to as a secant angle. These can occur both inside and outside the circle. So let's take a look at this. So we're trying to look at this in terms of arc measures, right? And so far, the only angles we really know anything in terms of arc measure are central angles, which we've defined, and inscribed angles. So what's going to be helpful for us will be to draw one of those angles. And what I'm going to do is I'm going to draw a chord EB here. So I'm going to draw chord EB, which we're allowed to do, because 2 points to define a line. And I now know several things here, okay? So let's think about some of the things we know. So it's an inscribed angle. So I know that angle BEC is equal to half the measure of arc BC, because inscribed angle is half the intercepted arc. Okay. And then I also know a few other things, right? So let's take a look at how that angle BEC relates to this triangle AEB, right? So, because somehow I want to relate these new angles that I have here to this angle that I'm looking at. So let's consider triangle BAE. Okay, and I know, for instance, because of the sum of the angles in a triangle is 180, I know that angle BAE plus angle ABE plus angle AEB is 180 degrees. And I also know that this angle BEC, that we know is half the measure of arc BC, I know that this angle is supplementary to angle AEB. So I can say that angle BEC plus angle AEB are 180 degrees because they form a linear pair. So angles in a linear pair are supplementary. Right? And supplementary angles, as you know, sum to 180 degrees. All right, so there's some things that we know, right? So what else can we say here? So if I were to subtract angle AEB from both of those equations, move the AEB over to that right-hand side and have the right-hand side of both of these equations be 180 degrees minus angle AEB, I guess I can go ahead and show that. So I can say angle BAE plus angle ABE is equal to 180 minus angle AEB, and angle BEC is equal to 180 minus angle AEB. And so because I have two expressions equal to the same expression, I can use my substitution property of equality to say that angle BAE plus angle ABE is equal to angle BEC. Right? So that's cool. So now I have this, that angle BEC is equal to, and I have this, that angle BEC is equal to. Let's think about what else we know about angle, which one? Angle ABE. So angle ABE, I could rename as angle DBE, right? Same angle. And thinking about it as angle DBE, we see that it's an inscribed angle, right? So I can think of angle ABE as half the measure of arc DE. Okay, so again, that's an inscribed angle. Cool. So now, because I'm trying to find the measure of BAC, well, angle BAC is really the same thing as angle BAE, right? So if I take the above equation and move that angle ABE over to the right, I have angle BAE equals angle BEC minus angle ABE. So I'm going to replace angle BAE with angle BAC. I'm going to replace angle BEC with, where is it? With half the measure of arc BC. And I'm going to replace, running out of colors, I'm going to replace angle ABE with half the measure of arc DE. And that's exactly what we were trying to show. So finally, I can say that angle BAC is equal to half, factoring that out, the measure of arc BC minus the measure of arc DE.